The prototype of this device is cylinder-shaped with 8 mm radius and 5 mm in length. There is a hole for insertion of 1.2 mm key wire. The device contains two pieces that catch each other with threads. The top piece functions as a cap. The second piece contains 3 grooves for the insertion of 3 balls. These balls are with 2.5 mm radius. The mechanism of locking is with the help of the balls in the cone-shaped grooves. In forward movement, balls move back to the base of the cone. During pulling back, balls move to the narrow part of the cone and lock the key wire. For the removal of devices, balls are magnetic active, and when a magnet applies to these devices, balls move back and release the key wire. To tighten the devices, a custom-made handle can be used. This handle locks forward movement of the device. In our study, to define the locking strength of the devices were placed on key wires and tightened. Increasing distraction force applied to the devices until failure. The maximum force and the total extension at the time of failure evaluated. After 10 experiments, the mean pull-out strength was 920 Newton, and the mean extension was 5 mm. To define the behavior of the devices against cyclic loading, devices were placed on key wires and tightened. Then 100 cyclic distraction forces of 450 Newton applied to these devices. Presence of the failure and maximum extension in the cycle evaluated. After 10 experiments, there were no failure of the device and the mean maximum extension was 1.2 mm. As a conclusion, for the treatment of fractures, these devices may be a new option and can be used after key wire placement to compress and fix the fracture. This study will be the first step of a new fixation technique, but we need more study.